All right, so as I mentioned, you need to be able to draw a block diagram for a transmission link along an optical fiber. So electrical pulse, convert it to light, send the light down the fiber optic, convert the light back to an electrical pulse, and then you have your electrical pulse out. Also, you can modulate multiple signals at along a fiber optic line. So when I was talking about before how you have a fiber optic line that has a huge potential range in frequencies, you can use those multiple frequencies to send multiple transmissions down the same medium. So here you'll have this is represented by multiple colored buses, red, green, or red, blue, and green. They're sent to a mixer. Then that mixed light is sent down the optical fiber, and then it is divided and then sent back along the bus. So you can have multiple transmissions going down the same segment of fiber. Now, there are three specific types of fiber optic line. You have single mode, multi-mode, and then the plastical optical fiber. Now, they all have various characteristics. Now, you'll have within multi-mode, you have both a stepped index and a graded index as well. So it all just varies how the light behaves going down the line. Single mode fiber is very easy. We're talking about the size of the fiber is usually less than 10 micrometers. So we're talking very thin lines. Along this line, they typically are able to send a single pulse. Then when you have a graded index, that's when you very tightly control the signal that's going down the line, and the end of the fiber is actually indexed or turned into a lens so that it causes the light to behave very predictably going down the fiber optic line. And then a step index fiber, it varies dramatically. So this is where you can get multiple frequencies bouncing off the interior walls of the fiber at various ranges. And there you're looking at about a 200 micrometer size of the actual fiber optic. Okay, so you have various types of fiber lines that serve various purposes. Now, the plastical optical fiber is typically, it works the same way, but instead of being made of glass, it's made of acrylic, which has a lower cost, but it's also a lower performance. So glass fiber optic is very expensive to produce and even more expensive to deploy. Acrylic fiber optic is a lot less expensive. Now, since the 1990s, they've improved the quality of the acrylic and have been able to purify it a lot better, so the connections are a lot better. That's when you saw the rise of things like optical audio cables. Do you guys have any home theater equipment at your home that has optical audio cables? You probably do, but you probably don't necessarily use them, because if you look at the back, it'll look like kind of the one end of a USB connection. It's a square thing, and it says like optical audio or something like that, and you actually use a fiber optic connection to go from the various pieces of home theater equipment. And technically it provides a much higher quality of audio signal. Explain the difference between a single mode and a multi-mode optical fiber. Pretty straightforward. A single mode optical fiber, like I said, is typically less than 10 micrometers in diameter and only allows a single path or a single frequency to run through that fiber, where a multi-mode fiber is considerably larger and you can have multiple paths for light to travel through. So you have you can have multiple frequencies going through at the same time, but there might be, it's not going, a single mode can be run for a lot longer distance than a multi-mode. A multi-mode, you're going to get a little bit of noise generated in the line, but it still is much better than using copper. Again, go back 2 slides and take a look at the diagram that was provided. Now, There are advantages and disadvantages, like I kind of just said. Single mode, you have a larger bandwidth, but again, you need larger bandwidth and a larger length and a narrow spectrum light source. So the equipment is actually much more expensive for single mode fibers. Multi-mode fibers, you're going to have signal degradation along the line, so you need to be able to regenerate that signal. So you have boxes that are put along the way to collect the light signal and then amplify it and continue sending it on. So retransmission signals. And again, the plastic cables, like I said, they are fairly recent development, lower quality but much lower cost for deployment. Typically used for short lengths. Advantages of optical fiber: basically made out of sand. Actually, technically it's glass for a lot of them, so there's a lot more of it than copper. Copper is expensive, sand is not. Again, no electromagnetic interference. You don't need to amplify it very much. Relative to copper, it's a lot lower maintenance, much thinner and lighter, so long length can be stretched out over lines or buried a lot easier. Usually, they're talking about stretching copper lines on telephone posts. Or stretching fiber optic lines along telephone poles. They typically do not do that. The most frequent use of optical fiber routing is actually underneath railroad tracks, because it's very easy to break a fiber optic line. A few years ago, at the corner of Wagar and Hilliard, over by where Magnificat is, there was a maintenance crew that was working, and they took out a fiber optic bundle right at that intersection, and they knocked out the phone and internet service for about 2/3 of Rocky River, and that was out for a couple of days. So that made the news. So they typically run optical fiber where it's not going to get messed with. Very few people are going to be digging under a railroad track. Okay, so they typically run them under railroad tracks. You'll see road crews under roads all the time, digging up roads, resurfacing, but not under railroad tracks. Satellites. With satellite systems, you have the information which is modulated to an orbiting spacecraft into an electromagnetic carrier wave. So it's radio frequency, just like before. And it bounces up, it goes up to the satellite, and then it's transmitted down. And it depends, the altitude of the satellite affects both the quality of the signal. The higher it is, the more powerful of a signal it needs to be able to send. But also the higher it is, the larger the range is. A lower orbit satellites have a much smaller footprint, but they tend to be, you don't need to send as powerful of a signal. So again, it comes down to a trade-off. Now, geosynchronous satellites the whole concept of geosynchronous satellites were proposed back in 1946 by science fiction author Arthur C. Clarke. Typically, you have the satellites orbiting the Earth along, going east to west, and they are between the tropics. And if any of you, how many of you guys have satellite TV at your house? Anyone? Now, I can pretty much guarantee you, since we're in the northern hemisphere, North America, that your satellite dish is going to be pointed south, because all of the satellites in geosynchronous orbit are over between the tropics. Okay? So they're typically going to get a much better satellite connection with the dish pointed south.
So west is bad?
Not necessarily. Is it really west? Make sure that it's actually west. What you think might be west might actually be south.
It's definitely west.
Pardon?
I said it's definitely west.
Well, it might not. Is it talking to a satellite, or is it talking to a retransmission station?
No.
It could be the satellite dish might not be pointed at a satellite. It's not really a satellite dish. It's technically called a reflector and a collector. The collector dish might be pointed in a certain direction because there's a retransmission station. Okay, so it gets that the retransmission station has dishes that are pointed south, getting the information from a satellite, and then it retransmits it in a certain direction. Okay, that is also very possible. Now, here's the way Here's a diagram from actually the original documentation on how these would work. Now, the advantage of a satellite link is its mobility. It could be placed anywhere. Okay, if you have a sky over you, you can have a satellite connection. You might not be able to have a cable connection or a DSL connection or a fiber connection, but if you have sky overhead, you can have a satellite. Now, the disadvantage of a satellite link are A, it's expensive to get something in orbit, and B, it is limited to microwave frequencies for range. So the bandwidth limitations are actually considerably lower than a fiber optic, and in some cases even lower than in copper. Now, also, satellite links are subject to interference. I know this because I used to live just north of a landing path at Hopkins. So every 3 to 5 minutes when an airplane would land, my satellite TV would flicker for a second. Sometimes it would be worse than others. Okay, it really depended. You can also have thunderstorms that interfere, and also with satellite links, unless it's encrypted on both ends, which honestly it usually is, satellite connections can be intercepted or picked up by unauthorized people if they're in that footprint area. So that, in a nutshell, is how satellites work. There's a lot of neat projects with satellites going on these days with making like CubeSats, which are very small satellites that are able to be launched, and they do all sorts of testing on these with these satellites. And when you think about it, they were using Nexus cell phones as a basis for these satellite systems. Well, when you think about what is a Nexus, or what does any smartphone have? It has a lot of processing power, first off. It has several different types of antennas. You have Bluetooth for short range, you have Wi-Fi for medium range, and then you have an actual cellular connection for a long range. So you have all these antennas that are on board. You have high-resolution optical cameras. You have batteries that last for a fair amount of time. You have a lot of storage medium on these phones. So making use of it as a satellite is not at all unreasonable if you want to collect a fair amount of data and then transmit it. So there's a bunch of projects that have been put up there to develop these inexpensive satellites. Problem is, when you get a lot of these little tiny satellites up in orbit, then creates a lot of debris, makes it difficult for navigation in orbit.